So when we graph, first step is to find the axis of symmetry. When we did that yesterday, it's always x equals, what was it? Do you remember? Opposite of b over 2a. Find the vertex, which is an ordered pair. This x value is the first thing in the vertex, and then we plug that in to get y. Then we are going to make a table of values. So we're going to put the vertex in the middle, and we're going to use our calculator to find other points. And then we will plot them to get our complete graph. So let's look at this one. Yesterday, the biggest problem I saw was positives and negatives that were getting people. If I look at this, remember a quadratic is ax squared plus bx plus c. A is the number in front of x. In front of x squared. B is the number in front of x, and c is our constant. So if I just have x squared, that's like 1x squared. So my a is 1. Do I have an x term? No. So if we don't have it, what's b?
0.
Okay. So when I did my the axis of symmetry, the opposite of 0 is still 0 over 2 times 1.
0.
0 divided by 2 is 0. Okay, so axis of symmetry, x equals 0. My vertex, 0 is the first point. How do we get y?
Do the equation.
My equation, y equals x squared. So y equals 0 squared. 0 squared is
0.
0. So what we're going to do is we're going to put this in the middle of our table. The vertex is in the middle. And I can plot that point. Here's 0, 0. Now I'm going to put in some more numbers. I want numbers bigger than 0 for my x, so I'm going to put in a 1 and a 2. And I also want smaller than 0, so negative 1 and negative 2. So that's why we put it in the middle, to remind ourselves we need numbers bigger and smaller. To get y, you are plugging all of these into the equation. The equation is just whatever you put in squared. So if I put in negative 2 squared, so negative 2 times negative 2, 4. So I can plot that. Negative 2, 1, 2, 3, 4. If I put in negative 1 squared means negative 1 times negative 1, which is 1. So negative 1, 1. If I put in a 1 squared, 1 times 1 is 1. If I put in a 2 squared, 2 times 2 is 4. And we should always get this shape because we said yesterday the graph is always a parabola, a U shape. We knew it was going to open up because my a was positive. It was a positive x squared. We just have a more accurate graph than we did yesterday because I have some exact points on it. So then you are going to connect those. It does keep going. We stopped plugging in points, but it keeps going in both directions, so you draw arrows on the ends to show that. The other two things that we're going to do today is answer domain and range. Domain is asking what x can be. And this is actually kind of nice because it is the exact same every single time. If I'm asking what x is you can have, we can plug anything into this. If I look at my equation, it's going to keep going to the left, it keeps going to the right. So my domain is always all real numbers. We can get any x we want. Range is talking about my y. The range is going to be pretty similar every time. If I look, my graph started at 0 and then went up. So this one is greater than or equal to 0. The 0 is because that was the y value of my vertex, that was my starting point. And it opened up, so it was everything greater than that. Okay, your range will always be greater than your vertex if your parabola opens up. If it opens down, you're getting everything smaller. so then it would be less than. So it'll be either y is greater than a number or y is less than. Any questions on that? I'm going to go to number 3 next. I've got a lot of examples on here, so we're going to jump around a little. So when I look at this, we have to first make sure we know what a and b are. A is the number in front of x squared. What is that number? B is the number in front of x. What is that number? Okay, so my axis is symmetry. The opposite of b, this is where people were having problems yesterday. The opposite of b, if b is -8, what's the opposite of -8?
Positive 8.
Okay. Over 2 times a. So I get 8 divided by -2, which is -4. So my axis is symmetry. X equals -4. So -4 is the x value in my vertex. All right, to put this in your calculator, you have to do the negative from our equation. We are replacing our x. So in that equation, you are going to, inside parentheses, put -4. I want everybody to type this in so we can make sure that we're getting the right thing. So type it in exactly how I have it written. You have a negative, parenthesis, -4 squared. What did you get when you plugged in that -4? You should get -1. Is that what everybody got? Okay. So, on here, the middle, we're going to put our vertex. -4, -1. Then we need x's smaller. So if you had -4 and you subtract, that's like -5, -6. And we need x's bigger, so -3, -2. We need numbers surrounding that. Okay, if you are using this kind of calculator, what you can do is use this up arrow, highlight the equation you just typed in, and hit enter, and it would bring it back to your screen. And you can go back and highlight where you had a -4, for instance, and change the 4 to a 6. And that's a shortcut, so you don't have to retype the whole thing. If you have the graphing calculator, everybody pay attention. If you are using this one, you hit second, and then enter. And it will bring back the equation you just typed in. You can use your arrows to go back and change things. So I want everyone to use that shortcut to go back and plug in -6 instead of -4. So we have to do second, enter. It brings it back. And you can use your arrows to change it. Maybe to -6, it should just type over it. Which is fine. You can go ahead and retype everything. This is just like faster.
Oh, I know how to do it. That was my first
Oh.
time putting in the property.
Did you get yours to work? Second enter. The 6s. And that way you don't have to retype the entire thing. have that? What'd you get when you plugged in -6?
-5.
-5. Okay, so then if you want to type in -5, if you have the graphing calculators, hit second enter, change your -6 to -5. If you have the other ones, you use the up arrow, highlight your equation, hit enter, and you can change it. So much faster than retyping every time. All right, what do you get when you put in -5? Okay. Do it again and change it to a -3. What do we get?
-2.
And when you plug in a -2, what do we get? Okay. What are you noticing about these points every time? We're getting the same y values back, aren't we? Let's graph them. -6, -5. -5, -2. -4, -1. -3, -2, -2, -5. So when you graph it, you connect those lines and put arrows on the ends. So from this, what's my domain every single time?
All real numbers.
Okay, this one, because it opens down, my range is less than or equal to. So if it opens up, your range is always greater than or equal to because it's going up. If it's going down, it's less than or equal to. Then that highest y value is just the y value from our vertex, which is -1. All right, questions? Okay, we're going to do another one until I see everybody actively putting numbers in the calculator and trying it. Okay, so let's go to number 4. I need to know that everyone can plug these in and get the right answers. So, what is my A value this time? What is my B? So the vertex, we always do opposite of B over 2A to get the axis of symmetry. So the opposite of 4 is -4 over 2 times -2. -4, -4 divided by -4 is 1. So my axis of symmetry is x equals 1. My vertex, my x value is 1. How do we find y?
Do the equation.
Yep, grab your calculator. You're going to type in -2, parenthesis, 1, put the square on the outside, plus 4, parenthesis, 1, plus 1. And what do you get? So that's the middle of my table. We should be able to go ahead and even do domain and range without our graph. What would our domain have to be? All real numbers every time. Does this one open up or down?
Down.
Down. If it opens down, we know we're hitting everything smaller, so less than or equal to. Where do we get this number from? The y of our vertex, less than or equal to 3. Or we can wait and get our graph. Okay, the x's, we have to put in things smaller and things bigger. All right. So I want you 3. You guys plug in 3. You guys plug in 2. You guys plug in 0. You guys put in -1. So everybody plug in their number on their calculator so you can tell me what you get when you put in your number. All right, so what do you get when you put in 3?
-5.
What about 2? When you put in 0. When you put in -1. Last row over there, you 4. What'd you get with -5? You might have had to just retype the equation. When you tried to do that second inner trick, it had more characters, and so it probably typed over as part of your equation. So if that happens, just retype it. So we graph them, -1, -5. 0, 1. 1, 3. 2, 1. 3, -5. So my graph should look like that. And we can see from that graph our range. We're getting everything less than this point. That point was 3, so y is less than 3. We were right. All right, one more for the day. Problem 6. Actually, no, let's do 7. What is my A value? 2. What is my B? 8. Okay. So the opposite of B would be a -8 over 2A, 2 times 2. So 2 times 2 is 4. -8 divided by 4 is -2. So the axis of symmetry is x equals -2. The x value of my vertex is -2. To get the y, we go to our calculator. We're going to type in 2, parentheses, -2 squared plus 8 times -2.
-8.
So that's my vertex. Okay. We have to plug in numbers smaller than -2. So maybe a -1 and a 0. Whoops, those are bigger, aren't they? Doesn't really matter which direction you go in the table as long as you do both ways. So if you did 0 and -1 first, that's fine. Smaller would be -3 and -4. Bigger, -1 and 0. But just as long as you get both sides, I don't care what order they're in your table. All right. I want you guys have -4, -3, -1. You 3 have 0. Plug it in. Tell me what you get. All right, what did -4 give us? 0. What's -3 give us? Okay, what's -1 give us? And what's 0 give us?
0.
Okay, so we have -4, 0, -3, -6, -2, -8, -1, -6, 0, 0. What's your domain? All real numbers every single time. This time, is it greater than or less than? Greater than or equal to our y value of the vertex, which is -8.